Hi, my name is Mary Seed. I'm a bedrock geologist with the Illinois State Geological Survey, and I make maps. I go out in the field with my map board right here. It holds the map and it keeps it from getting wet in the rain, along with my field book right in the rain. So when it's raining outside or I drop it in a stream, it's all good. The pages are waterproof. You can write with pencil and it stays for years. First thing that I need to do when I get to this area, before I start taking a note, I need to figure out where I am. What I use my compass in conjunction with the map, and I can take the attitude or the direction, the compass direction, the cardinal direction of this stream that's flowing down, and I can see that that stream is flowing 10 degrees west of north. And now what I can do is I can line my map up with north on the map and adjust that with my compass. So now I can line my compass up 10 degrees west of north on the map and determine where I am. And that's the most important thing in getting a note, because if you take a great note but the location is wrong, then you can't reduplicate that. Now, if you get a great location and you make a horrible note, at least you can return with other people and other geologists to tell what's going on there and take a better note. Let's say this is my first stop, 1. I'll mark that on the topographic base map provided by the USGS, and I'll open up my field book, get my pencil, get out some lead, open to the first page, start by writing the quad that I'm in, which is the Pomona Quad. I then write the date so that I can look back on that note and know when I took the note. Sometimes it helps to put the weather, so it's partly cloudy, it's about 60 degrees out, it's slightly breezy, and that gives me a context for the note that I just took. First I'll start by describing primary features of the rock. Here, we have a great natural exposure of sandstone. I say that because I've been here already, and I've mapped this area. What we'll usually do is we'll use our rock hammer, we'll hammer off a piece, and we'll get a fresh surface of the rock. I'll start taking a note on that. We'll say what the rock looks like on the weathered surface, what it looks like on a fresh surface, and we'll note primary sedimentary structures. We'll describe the color of the rock, its grain size, its sorting, so are the grains fine-grained or coarse-grained, or are they mixed? Then the bedding type, whether the bedding is thin-bedded or thick-bedded. Bedding is the separations in the rock that tell us how much sediment was being deposited at that time. Water drips down from above and concentrates along bedding, because the bedding is a weak point in the rock. Another weak point in the rock is the jointing, and you can see the jointing in the rock over my shoulder here. And that jointing is something that we take note of. The jointing is something that can be measured, and that can be measured with a compass, a Brunton compass. It's a geological compass, and it's a very high-tech compass. It has angles and ways that we can measure the rock, such as if the rock is dipping at a certain degree, we can measure how much it's dipping by leveling the bubble level in the center here. At the same time, we can measure what direction those joints are going in by the north-south arrow here with the degrees along the side of the compass. Right in front of us we have an outcrop. Now this outcrop is probably 30 feet in height. You might ask, how do we know that this is a 30-foot bluff in front of us? When we have a straight bluff line like this, it's very hard to use the compass to do anything. So what you really need to do is rappel with a rope from the top, rope off at a tree, and come down with a staff, a 5-foot staff, let's say, and measure by hand as you rappel yourself down that bluff. Basically, when we have rock outcropping on the surface and it's on a slope, let's say in a riverbed, then we can use the compass with a particular technique of sighting through that compass to measure our eye height. And from our eye height, we can count the number of eye heights that it takes to get to the top of that outcrop. And let's say my eye height is 5 feet, and there are 12 eye heights. That equals a 60-foot height of that outcrop if it was a bluff line. On a cloudy day, let's say, or if it's raining, we have to estimate our elevation based on our location. So that's why it's very important to know which ravine we're in and what part of the map we're on. On this scale of map, even though it's a very detailed scale, it's still not detailed enough to be able to show some small features like ravines that you may think show up on a map. So it takes quite a bit of time and experience to know how to use these topographic maps and to get a feel for the scale. That's a really big part of mapping, is the scale at which you're mapping. In some areas, like in Illinois, where we have lots of soil cover and vegetation, it covered up the bedrock and made that bedrock very hard to see and made very few outcrops available to a bedrock geologist like myself. Now, in those areas, oftentimes we have to do our best to connect the dots between two known points that we do have outcrops. If that space, that distance is too far, then we'll try to drill a hole between them so we can have another control point. We may need to drill down about 300 feet to get an idea for what the stratigraphy is in that area. Now, the stratigraphy is the organization of rock formations based on their age. The oldest ones at the bottom and the youngest ones at the top. The hazards of geologic mapping include poison ivy, rocks, steep bluffs, ravines, slippery moss on rocks, twigs, barbed wire fences, snakes, ticks, and chiggers. Except that about half of those hazards can be mitigated by doing mapping in the wintertime. We don't do a lot of mapping in the summer because the humidity is so bad and the heat is so bad that you can only last about a half a day. As far as the winter is concerned, it's cool out, your body wants to stay warm, it wants to keep moving, so you cover lots more ground, probably about 3 to 4 miles in a day, round trip. And in the summertime, you go maybe a mile or two. Now we're going to transition from the field to the office, getting these observations that we've made out in the field down on paper is what makes the map what it is and makes it so that we can distribute it and people can use the map.